we're all wondering how AI is getting closer and closer to actually thinking like us, especially when it comes to reasoning. So today we're diving deep into this technical report on Keemi K 1.5. It's this brand new AI model, and let me tell you, it's really making waves. So what we're going to try to do today is figure out how Keemi K 1.5 is pushing the limits of AI, especially how it uses something called reinforcement learning to basically learn how to think. Get this. It's like the AI is playing a game to get smarter.
Yeah, and what's really cool here is that this report isn't just theory, it's showing us how Keemi K 1.5 is actually being trained.
Exactly. And another thing is that Keemi K 1.5 is multimodal, meaning it can work with, different types of data, not just text. But we'll get to that later. First, let's break down this whole reinforcement learning thing. I know typical language models are trained on these massive data sets, but that seems kind of limited, right?
You're right, there is a limit there. Traditional training is like, giving the AI a textbook and saying, figure it out. But that doesn't always mean the AI really understands it, or that it can actually use what it learned in new situations.
So reinforcement learning is like a completely different approach.
Exactly. Imagine instead of a textbook, you give the AI a game to play, a complex game. And it learns by experimenting, trying different things and getting feedback rewards for doing well and penalties for mistakes.
So it's like the AI is learning by trial and error, kind of like how we do when we're learning something new.
Exactly. And that's what makes Keemi K 1.5 so interesting. It doesn't just follow instructions. It actually plans, it evaluates, it explores different ways to solve a problem, almost like, how a human would approach a challenge.
That's crazy. So how does it even know where to start? Does someone have to walk it through every little step?
That's one of the big breakthroughs here, actually. Keemi K 1.5 uses this technique called chain of thought, where it takes a problem and breaks it down into these smaller steps, then figures out the best way to reach the solution. It's almost like it's thinking out loud.
I'm impressed already, but wouldn't all this thinking take forever? AI isn't exactly known for being super fast.
That's a really good point, and it brings us to this idea of context length. It's basically like giving the AI more thinking time by letting it look at a lot more information at once. Keemi K 1.5 can actually handle 128,000 tokens, which is like a measure of how much information it can process at once. That's way more than most AI models can handle.
So the longer the context, the deeper the AI can think.
Exactly. And that deeper thinking lets it reason in a more complex way.
This is getting pretty mind-blowing. We've got AI playing games, thinking deeply, and now this whole long context thing. What else is there?
Well, remember how we talked about Keemi K 1.5 breaking down problems into smaller steps? There's this really clever technique they use called partial rollout. Basically, if a problem takes a lot of thinking, it gets split up into chunks. And those chunks are spread out over multiple training sessions.
So it's like breaking up a marathon into shorter runs. That makes sense.
Right, and it's all about making the learning process more efficient, but without sacrificing the complexity of what's being learned.
Okay, so I'm starting to get how Keemi K 1.5 is getting closer to human level thinking. But I got to ask, we've been talking about text this whole time. Can this AI understand images too?
That's actually one of the most exciting parts. Keemi K 1.5 is what we call multimodal, meaning it's trained on both text and visual data. It can understand and reason about images, which opens up a whole new world of possibilities.
So it's like it can actually see and make sense of what it's seeing. That's incredible.
It is. And being multimodal means Keemi K 1.5 can tackle real-world problems in ways most AI can't. Think about self-driving cars. If they could really understand their surroundings visually, it would be a huge jump forward for, safety and autonomy.
I'm definitely seeing the potential here. But can this AI actually code? I mean, that's a real test of problem solving, right?
You're totally right. And Keemi K 1.5 can actually generate its own test cases for coding problems to make sure its solutions are, practical and that they work well.
Wait, so it's not just writing code, it's testing it too. That's next level.
It is, and that's another place where that long context we talk about comes in. There's this technique called long too short, where the thinking skills from that long context model get transferred to a smaller, more efficient short context model.
So it's like taking all that complex reasoning and making it more streamlined and practical.
Exactly. It's like distilling the essence of its problem-solving abilities. And the results, well, they speak for themselves. Keemi K 1.5 is getting state-of-the-art results on all these benchmarks, including some really tough math and coding challenges. It actually beat out a bunch of human programmers on this coding platform called Code Forces. It's ranked in the 94th percentile. I mean, That's amazing.
Seriously, that means it's like outperforming most humans at coding. I knew this AI was impressive, but that's a whole other level.
It really is. And you know what's interesting? When the researchers did these things called ablation studies, which basically means testing different factors, they found that scaling up that context length is just as important as making the model bigger.
So it's not just about how big the AI is, it's about how deeply it can think.
Exactly. Keemi K 1.5 is showing us that this focused way of training, especially with the context length and reinforcement learning, can lead to some really groundbreaking advances in what AI can do.
This has been such an eye-opening deep dive so far. We've gone from AI playing games to understanding images to actually writing and testing code. Like, where do we even go from here?
Well, there's so much more to unpack. We've only just scratched the surface of what Keemi K 1.5 can do.
I can't wait to dive deeper. We'll be right back to continue this incredible journey into the world of Keemi K 1.5 and what it means for the future of AI.
So, before the break, we were talking about how Keemi K 1.5 uses that chain of thought thing to, like, break down problems and think through them, almost like it's, writing out its thought process.
Yeah, that was a pretty wild concept to wrap my head around.
It is, and it actually connects to another really interesting aspect of AI, this whole idea of planning.
Wait, so we've got AI playing games, thinking deeply, and now it's planning things out too. What's next? Is it going to organize my calendar?
Not quite. But the ideas are similar. See, traditional AI planning often uses these, like, really complex systems to explore all the possible solutions. Like, imagine trying to map out every single move in a chess game.
Yeah, that sounds insanely complicated.
It can be. But Kimi K1.5 is different. It's learning to do this planning internally as part of its reasoning process. Remember context length. Well, the bigger that context is, the more space the AI has to, explore different paths and make plans without needing all those complex external systems.
So it's like having a bigger mental workspace to play with. That makes sense.
Exactly. It's all about making the AI's reasoning more efficient and, dare I say, more human-like.
You mentioned something earlier that I wanted to circle back to. These value functions in traditional reinforcement learning, those are used to like help the AI figure out which actions are more likely to lead to good outcomes.
That's right. Think of him like a guide,
Yeah.
telling the AI, hey, doing this is probably going to get you a reward.
But I have a feeling Kimi K 1.5 might be doing things a bit differently here.
You're really picking up on the nuances. That's great. The researchers actually found that the typical way of using those value functions, it's not always the best when you're training AI to generate these really long chains of thought.
Okay, before we go any further, can you remind me what credit assignment means in this context? It's been a while since my AI 101 class.
Of course. So credit assignment is basically figuring out which of the AI's actions contributed to the final result,
Okay.
whether it's a success or a failure.
Gotcha. So what's the issue with the old way when you have those really long thought processes?
Well, imagine the AI is working through this super complicated problem, and it makes a mistake early on, but then it, like, recovers and eventually finds the right solution. Kind of like how we learn, right? We all make mistakes along the way.
Yeah, I've definitely made my fair share of those.
Exactly. But with, traditional value-based reinforcement learning, that early mistake could get penalized really heavily, even though the AI ultimately got it right in the end.
Ah, I see. So it's like focusing on the stumble instead of the fact that it, got back up and kept going.
Exactly. And that can kind of discourage the AI from exploring different ways of thinking, even if those thought processes could lead to some valuable learning experiences.
So it sounds like Kimi K 1.5 is designed to like embrace those mistakes as of the learning process.
Exactly. The focus is on rewarding the final outcome. Did it get to the right answer? While letting the AI explore freely and learn from those explorations. That helps it get better at problem solving, like figuring out when it made an error, backtracking, refining its solutions.
This is fascinating stuff, but I'm curious, if they're not using those value functions the traditional way, how do they keep the AI from like going off on a tangent, generating these super long, rambling responses that never end?
That's where this links penalty thing comes in. Remember how we talked about Keemi K 1.5 being able to produce those, super long outputs?
Yeah, like the AI equivalent of a never-ending story.
Exactly. So they actually introduced this, like, length-based reward during training to encourage the model to be concise, to get to the point.
It's like saying, all right, Kimi, wrap it up.
You got it. It's all about finding that balance between exploration and efficiency.
This all ties back to that idea of scaling that context length for better reasoning. But I gotta wonder, doesn't processing all that extra information require a ton of computing power?
That's a great question, and it's a valid concern. But the Keemi team was really smart about their infrastructure. They developed some, clever ways to handle the demands of this long context reinforcement learning, like breaking those long training sequences into smaller, more manageable pieces.
So they're finding ways to like streamline the training process itself.
Exactly. They're using techniques like partial rollouts and asynchronous processing, which basically lets the system handle multiple tasks at the same time. And that speeds things up considerably.
Sounds incredibly sophisticated. But realistically, is this kind of training even possible with the hardware we have today? It just seems like it would require a crazy amount of computing power.
That's another area where the Kimi team really innovated. They actually developed this hybrid system that seamlessly switches back and forth between training and inference tasks to make the most of the resources available.
So it's like the AI can switch between learning mode and thinking mode.
Exactly. It's super efficient.
This is all super impressive, but I'm thinking about, the practical side of things. We've talked about AI writing code and solving math problems, but how does this translate to real-world things that, like, everyday people would use?
That's where that multimodal aspect of Keemi K 1.5 really shines. Remember, it's not just processing text, it's working with visual information too.
Right. It can actually see the world around it.
Exactly. And that opens up a ton of possibilities. Imagine AI assistants that don't just understand what you say, but can also interpret visual cues. Like you could point at something and say, hey, remind me to buy more of that later.
That's like having an AI companion that really understands your world.
Right. Or think about self-driving cars that can, reason about their surroundings in a much deeper way. Not just recognizing objects, but understanding the context of those objects and predicting what they might do.
That's a whole new level of intelligence on the road and safety, too. I'm starting to see how this could change so many industries.
And it goes beyond just practical applications. Keemi K 1.5 is making us rethink what intelligence even means. Like, if AI can learn from its mistakes, plan ahead, and reason about the world, what other human-like abilities might we see in the future?
That's a really profound question. Keemi K 1.5 is definitely a game changer, and it feels like we've only scratched the surface of what it can do.
Absolutely. There's still so much to explore and discover.
Well, luckily, we have a whole other segment to dig into this. We'll be right back after a quick break to talk about how Keemi K 1.5 stacks up against, real-world challenges and benchmarks.
So, welcome back to the deep dive.
Before the break, we were like totally blown away by how Keemi K 1.5 is not just some theoretical idea, it's actually getting like amazing results in, real world tests.
Yeah, and it's important to remember that those results are coming from, some pretty rigorous benchmarks.
You're right. We touched on that a little bit earlier, but I think it's worth digging a little deeper. Like, what kind of benchmarks are we talking about here?
Well, to test its coding skills, they put Keemi K 1.5 through its paces on Codeforces. It's this popular platform where, programmers compete against each other.
So it was going head to head with like real human coders. That's intense.
It is. And get this,
Yeah.
it actually achieved rankings in the 94th percentile.
Wow. So it's outperforming like the vast majority of human programmers. I mean, that's more than just a coding assistant at that point. It's like serious competition.
Oh, absolutely. And its skills go beyond just coding. They also tested Keemi K 1.5 on some challenging math benchmarks, like the AA, which is this really competitive exam for high school students.
That's a serious test of, problem-solving skills. How'd it do?
It scored a 77.5, which is considered really impressive.
It makes you wonder if this AI could pass, like, my college exams, haha. But let's talk about the multimodal side of things. We know Keemi K 1.5 can handle both text and images. But, like, how do you even test that?
There are specific benchmarks designed for multimodal AI, like MathVista and MMU.
So I'm guessing those involve some, like, visual problem solving.
You got it.
Yeah.
MathVista, for example, challenges the AI to understand math concepts that are presented visually, like in diagrams or charts.
So it's not just crunching numbers, it's actually, like, interpreting visual information and applying, mathematical reasoning to it.
Exactly. And Keemi K 1.5 is getting state-of-the-art results on those benchmarks, which proves it can really blend those different types of information.
This is all so exciting, but I also kind of want to talk about, like, limitations. We've covered all the amazing things Keemi K 1.5 can do, but what are some of the challenges that are still out there?
That's a really important question. I think one of the biggest challenges is just the sheer amount of computing power that's needed to, train and run these large multimodal models.
Right, we talked about needing like specialized infrastructure and efficient training methods.
Exactly.
Yeah.
And even with those advancements,
Yeah.
we still have a ways to go in
Hmm.
terms of making this technology more accessible and, scalable.
So we're not all going to have our own personal Keemi K 1.5 assistants anytime soon.
Haha, not quite.
Yeah.
But, the progress that's being made is amazing, and the possibilities for the future are huge.
And another challenge we touched on was, that potential for the AI to kind of overthink
Yeah,
and produce those like really long, rambling responses. How are researchers dealing with that?
that's definitely an ongoing area of research. One approach is to refine the reward systems during training to encourage the model to be more concise and efficient in its reasoning. It's all about finding that sweet spot between, deep thinking and getting straight to the point.
It sounds like a delicate balancing act for sure. But let's take a minute to think about everything we've learned today. We started with this idea of reinforcement learning and how it's like changing the whole landscape of AI.
Yeah, we explored how Keemi K 1.5 is using reinforcement learning to develop, these human-like reasoning skills like planning, evaluating, and learning from its mistakes.
We talked about the importance of context length and how that allows for like deeper thinking and more complex problem solving.
And we saw how Keemi K 1.5s are really pushing the limits of multimodal AI, integrating text and vision to get these impressive results on real-world benchmarks.
It's been an incredible journey through the cutting edge of AI, that's for sure. So what's the key takeaway for our listeners?
I'd say the key takeaway is that AI is evolving at an absolutely astonishing pace. Keemi K 1.5 is a testament to the power of these innovative training techniques.
Yeah.
And it shows the potential for AI to, not just mimic human intelligence, but to actually understand and reason about the world.
It's both exciting and like a little bit daunting to think about what this all means for the future, wouldn't you say? I mean, one thing's for sure, the future of AI is going to be fascinating.
Absolutely.
And on that note, we're going to wrap up this deep dive into the world of Keemi K 1.5. Keep that curiosity alive, never stop learning, and who knows, maybe you'll be the one to create the next breakthrough in AI. Until next time.